Hello guys, this is Paul McWhorter with TopTechBoy.com, and we are here today with lesson number 49 in our incredible tutorial series where you are learning artificial intelligence on the Jetson Nano. I'm going to need you to pour yourself a nice big mug of iced coffee. And I'm going to need you to get out your Jetson Nano gear, and I'm going to need you to get ready to learn some cool new stuff. Hey, as always, I want to give a shout out to you guys who are helping me out over at Patreon. Your help is what motivates me to keep this great educational material coming. You guys that are not helping me out yet, think about looking in the description down below. There is a link over to my Patreon account. Think about hopping on over there and hooking a brother up. But enough of this shameless self-promotion. Let's jump in and talk about what we are going to learn today. But first, I must give you a little heads up. You see this haircut? Yep. The barbershops are closed still as of the time of making this video due to the coronavirus. And therefore, I finally got so sick of shaggy hair that yes, I got out the old dog clippers and I cut my own hair with dog clippers. So you might not like it, but at least it's not shaggy. Leave a comment down below. How many of you guys have also had to either cut your own hair or find a family member who was brave enough to try to cut your hair? Not perfect, but it's better than having shaggy hair. But enough of this small talk. Let's jump in and talk about what we're going to do today. Okay, so far in the first 48 lessons, we've done some really cool stuff. And we've gotten up to the point that you can not only find faces in a picture, but you can train it to know who's who. And you can not only detect a face, but you can recognize a face. And that's pretty neat stuff. But so far, all of our work has really been based on open source types of resources, libraries like OpenCV running inside of Python. Those libraries we were using for face detection and face recognition. But those are all sort of generic platform type of resources. But if we really want to take our artificial intelligence to the next level, we need to start using some libraries that were developed by NVIDIA specifically for the Jetson Nano. Because, for example, there's a lot of things that you might want to detect besides just face detection and face identification. You might want to find other things, and you might actually want to begin to train networks. So to start taking our artificial intelligence to those next levels, it is time for us to start moving towards some of those NVIDIA Jetson specific packages. And so that's what we're going to be doing today. Is we're going to be installing some of those NVIDIA libraries. So it's going to be one of those lessons where we are doing a certain amount of installations, and you can follow along with me step by step. But I will try to, at the end, go ahead and write one program, and the simple program that I will be doing today will be looking at object identification, where we're going to be putting some objects in front of the camera and see if we can identify what it is. So I will go ahead and I will get out of your way, and then I will be firing up a terminal. And that looks like it is already pretty much in the right position. So we are going to begin by doing a sudo apt-get update to make sure that we have the latest and greatest of everything. How long this takes is going to depend on how long it's been since you've done an update. If it's been a long time, this could take a while. If you've done one recently, as I have, then it doesn't take very long. So it looks like we are ready for the next step. And what we're going to need to do is we're going to need to install some software that will allow us to install these libraries. So there's some tools that we need. So we will need to do a sudo apt-get and then install. So we're going to do a sudo apt-get and install like that. And what do we need? There's a program called Git, G-I-T, that allows us to get things from GitHub. We are going to need CMake so that we can compile things. We're going to need a Python library that is called libpython3-dev, and then Python 3-NumPy. Okay, and so take a quick look at that. Oh my goodness, I know you guys hate it. Nothing makes my audience more unhappy than for me to be sitting in front of what I'm typing. So I'll let you take a look at that. Python 3-NumPy. Those are the things that we are going to install. And so we're going to go ahead and click enter. And these really usually don't take very long to install. So I'll just sit here with you. Whoa, lib Python 3. Oh, I put 2 dashes. My bad. Hopefully you caught that. Library lib Python 3 1-dev. I will take that out. And then these hopefully won't take very long to install. It looks like I'd already installed these, so yours is going to take a little bit longer, but probably not very much longer than what it took me. Okay, this I can't remember if I mentioned, but this what I'm doing is I'm following a tutorial that was put together by Dusty at NVIDIA, and want to give him a shout out because he really took some very complicated software and reduced it down to some libraries that can be very easily called from Python. So he took some very powerful packages and reduced it down to some simple libraries that we're able to use very powerfully. So shout out to Dusty. Okay, so we did our installations, and now I'm going to go ahead and CD down into downloads. Okay, CD into downloads. I guess it depends on where you're starting, so I'm going to do a CD home, like go home with the squiggly and then slash downloads, and that will work for you no matter where you are. Okay, now if I do an ls, I am down into downloads, and you can see some of those libraries that we had installed before. It looks like the Coda OSS, you remember we did that, and then the dlib was one of those libraries we needed for face recognition. So we've been down in this folder before. But we're going to go ahead now and put in the resources to install these NVIDIA libraries. So what I'm going to need you to do is do a git git, and then clone. We're going to clone, and then we're going to clone -- recursive. Now, what does a recursive clone mean? That's when we go to GitHub, we don't just get the main folder, we dig down into the folders, and we get all the folders and all the files that are below the root. So recursive means you're going to get everything that's there as part of this package, and then we're going to go to HTTPS, the location of all this stuff, // github github.com /dusty-nv. Do you see that? Dusty-nv. We're almost there. /Jetson Inference. Okay, and you could see all that. Jetson-Inference. Okay. Git clone space -- recursive space https / github.com /dusty-nv /jetson-inference. With a little luck, boom, it is cloning. I think this is going to work. I'm just going to wait because this just takes a couple of minutes, and so we'll just sit and chat while we're waiting for this to download. And I think I can now safely go back to this view without having you yell at me. It's going along pretty well here. Then after this, what we'll do is we will we're going to have to compile some of this stuff that we're downloading. And so, okay, that looks good. So we're still in download. And now if I do an ls, you can see that we now have a new folder, which is called Jetson Inference. So that is where it put all of that good stuff. So we are going to CD down into Jetson Inference that we just created. Okay, now that we're in that folder, we need to make a build folder. So we're going to do an mkdir build, and now ls, and you can see that we just created this nice build folder. Okay, and so we are going to cd down into build, so we will be building in the build folder. And now we are in build. That looks good, so we're going to do a cmake, and then we are going to do a ... and a slash, and this should start putting these packages together with a little luck. Looks like it's going. Okay, now what I do believe that this could take like 30 minutes, but in the middle of this it's going to stop and it's going to come up with like a green and white dialog box, and that dialog box is going to ask you for certain things to install. And so what I'm going to do is I'm going to pause this operation and let all this stuff happen, and then I'll come back when that green dialog box pops up asking you for what to download. Okay, and so I will check back with you in a minute. Okay, actually happened quicker than what I thought it would, but we will go ahead here. And these are pre-trained models that allow you to do certain things. And these models are very complicated. I mean, these models would take very, very large amount of resources to put together, and much more complicated than what we could do by ourselves from scratch. So we're taking advantage of artificial intelligence models and training sets that other people have already put together. And so the good news is they are free. And so on these models, I'm just going to come up to all, and with the all selected, if I hit my space bar, do you see how it puts an asterisk there? That is going to get all of the image recognition models. But there's another type of model, so I don't need to come in and select each one of these because I got them all. But there's also detection models, so you've got to carefully come down and then come down, and you see here are the detection models. So I'm going to get all detection models. Okay, and then we are going to come in, and then there is semantic segmentation. I'm not going to select all of those. I'm just going to take the default ones, which they've already selected, which is 24, 25, and 27, and 29, and 31, and 33. Wow, they got already a lot of those, but I'm just going to keep the ones that they selected. I don't want the semantic segmentation legacy models, so I'm not going to choose any of those. And then finally, the image processing all models, I'm going to get all of them, which would be the deep homography COCO and the super resolution. Okay, and so those are interesting models. I will just take a second and say, what is the difference between image recognition, object detection, and semantic segmentation? Okay, image recognition, what that is, you try to have kind of a clear field of view, and then you put something like a cup, and so you would want nothing in the picture but the cup, and then it would identify it like what's in the picture, a cup or a pen or a bottle. So you show it a kind of clear picture of something, and it tells you what it is. That would be image recognition. Now, object detection is a lot more complicated. That's like where you would look at the room and it would find in box all the things it recognizes, like, oh, here's a bottle, here's a chair, here's a person. And so object detection is looking at a complicated scene and finding and localizing or boxing a lot of different things, to where the image recognition is a lot simpler, where you need to kind of show it clearly a picture of something, and then it tells you this is a dog, this is a cat, that type of thing. Okay, so that makes sense. So we are going to go ahead and make sure you come down with your arrow key and be over OK, and then click enter. Now we are downloading a lot of stuff here, so this is actually where I think it could take 45 minutes, and so this is where I'm now going to pause the video, and after all of these things get downloaded, then I'll come back, because the next thing that's going to pop up is it's going to ask you some questions about PITorch, another one of those green dialog boxes. I'll come back and help you with that in just a minute. And we are back, and as promised, it is asking us about PITorch. And yes, indeed, while we are doing our installations, we might as well go ahead and install PITorch. What is PITorch? PITorch is something that allows you to sort of retrain these networks that we're downloading. So if we wanted to create some custom image recognition capability, we would start with one of the existing pre-trained models, and then we would retrain it and tweak it for our specific application. We'll talk more about that later, but we're going to go ahead and install PITorch. You see the first option is PITorch 1.1 for Python 2.7. We want to not do that. We want to arrow down. You see how I'm arrowing up and down? You want to arrow down to the PITorch 1.1.0 for Python 3.6. and then spacebar puts an asterisk there. We should be good to go. If I click enter, that is on the OK. The OK is highlighted, so with a click enter, it should go. And let's see what happens here. It looks like this is going. All right, I will check back with you after PITorch is installed. And it looks like that installed everything without trouble. And so I do believe that we had just done the cmake command. And so now after cmake, we need to do make. So we will do make and then -J, $, and then the letters NPROC. So we're going to do a make -J $, open parenthesis, NPROC, close parenthesis, and let's see if this is going to be one that takes a long time. Okay, it looks like it is going. I can't remember, I've done this a couple of times, but I can't remember which are the long ones and which are the short ones. This might be another long one, and so I will let you watch your screen by yourself, and I will catch up with you. And it looks like that worked without incident, and we are getting really close to getting this done. We've done the cmaking and the making. We need to now do the installing, so we will do sudo and then make and then install, like that. Sudo make install. You can see that completely. Enter. And this is flying through this. This might go quickly, so let's see if maybe we can just sit and chat as this one goes through. But what we'll do here, we're getting really close. After we get done with this, there's one more command, and then there's another little helper software that we're going to go ahead and install, because sometimes these installations, let's just take a video and get it done. Okay, that worked good, and that was the sudo make install. Now we need to get everything synchronized, so we will say sudo ld config, and this should just run really fast. Sudo ld config. Yeah, that went really fast. And now there is another software that with these reference things, we need to kind of understand what the parameters of our webcams are. Now, if you're using the Raspberry Pi camera, you know that as soon as you launch that GStreamer command, it gives you that printout down below of all the different frame rates and resolutions that the camera is capable of. And so for the Raspberry Pi camera, you can just grab it off of that. When you launch it, it gives you what your options and parameters are. But if you're using a webcam, you need a helpful program to help you find the properties of the webcam, and that is the program v4l.utils. And so I need you to do a sudo, oh, you guys are going to get mad, sudo apt-get install v4l utils. Okay, and so we'll hit an enter there, and that is building, and that got installed very quickly. And now what that program is going to let us do later on, it is going to let us sort of query our webcams to see what resolutions they're capable of, and therefore we'll know suitable parameters to write into our programs. Okay, I do think one more thing, we need to make sure that we got the PITorch and the PITorch installed correctly. And so let's go ahead and just type in Python 3, and we'll get to the Python 3 interpreter. And what we can do is just type in import torch, and if PyTorch was installed correctly, you see it does that without an error. Now, if you got an import torch error that like torch wasn't found, then your torch didn't install right, and you've got to go in and kind of figure out what happened. The other one we needed was torch vision, which should have come with this torch vision. Okay, so we've got things really good. We've got a nice, good Jetpack 4.3 installed, and we've got these inferencing and object detection and image recognition libraries installed, and we have PyTorch installed. So those are all very good things. Plus, we got that VL4 program installed. So I'm going to do a Control-D to get out of that, and that all looks really good. You know what? I think that we are ready to try to go ahead and write a quick program, okay? Because after all of this installation, we do kind of owe it to ourselves to have a little bit of fun. So I do have the PyPro folder. I'm opening up code OSS, and then I have created a new folder. Let's see, this new folder is called NVIDIA. Okay, and inside the NVIDIA folder, I am going to create a new file. So I'll come up and I will put a plus for a new file, and then I think this is going to be my, and then I will call it my identify dash first for my first try.py, something like that. That's kind of small for you guys to see, but you can name a file on your own, right? And now we have a fresh, new, ready to go Python file that we are ready to write a program. Okay, now one of the cool things that we just did was we installed some new libraries, and we're going to be using those libraries. So I'm going to import Jetson.Inference, and import Jetson.utils. So those are the two libraries we are going to be using. Just for fun, you're always kind of worried, did they really get installed? So I'm going to right mouse click, run Python file in terminal, and this doesn't do anything, but it did load those libraries. And so that is good news, that means our installs went correctly. But yes, we will in fact be doing something a little more exciting than that. We will write a really quick program. So we have installed the libraries, we have loaded the libraries. Now we have to create an object or an image recognition network, okay? And so we're just going to call it net. And this is where we're going to use that training model that we downloaded here in those last steps. So how do we create our network? Well, I'm going to name it net. You can name yours whatever you want, but I'm going to call mine net, and then it's going to go out to Jetson.Inference. That's that library that we just loaded, and then it is going to do a detect net. Okay, now we have to tell it which network model to use. Now remember, we downloaded them all, so there's a lot of different image identification networks that are training data that we trained models that we downloaded. And so the one we're going to use is SSD-MobileNet-V2. Okay, and then we need to set a threshold. Okay, is equal to 0.5. And so if you set the threshold low, it's going to recognize a lot of stuff. If you set the threshold high, it's not going to recognize much stuff. And so let's say that I have a pen. That's wrong, not a good example. Let's say I have a cup, okay? If I set the threshold to 0.1, it's going to always recognize the cup, but it might recognize the microphone as a cup. If I put the threshold at 99 or 0.99, then it would not have any false positives, but it might miss some cups. And so about a 0.5 is not perfect, but usually most things it will get right. You can play around with that threshold after we get the program written. All right. Now, one of the things that you're going to see now that we're using these Jetson utilities, we're not going to do the CV2 create a camera using CV2, but what we're going to, you know how we created those video capture objects, we're going to create our camera object using the Jetson utilities. So what I'm going to do is I'm going to say my cam is going to be equal to Jetson, and this is before I think we use like CV2.video capture, but we're using the Jetson utilities now. So we're going to say Jetson.utils. I'm going to create a GST camera, and now I need to give it the resolution. Well, I've already looked this up, so I know that my resolution is 640 by 480 will work, and then I'm going to use my webcam, which is going to be /dev/video1. And if you were using the Raspberry Pi camera, then you would need to use that cam set, that long string that we use to create a video capture object. Well, you would need to use that long cam set string here. But we indeed are using the webcam, and so I can just use this. Let me kind of show you that you got to make sure that this resolution that you set is one that is supported by the camera. And so I am going to run over here and get a useful command. That's not the right thing. I keep useful commands over here, and this is the command. Remember, we installed VL4, and so now I will come back to a terminal, and now I will paste, and then I'll explain what I'm doing. Okay, and I will in fact get out of your way. All right, so we give the command v4l2 dash, you know what I'm going to do? I'm sorry. I'm going to change directory back to my home so that you can see more of the line easier. And now I will explain the command. You do v4l2 dash ctl, and then you got to tell it, this is like saying, tell me what the camera parameters are. And then you've got to do a -d, which says, which device are you looking for? Well, /dev/video0 would be looking at my Pi cam because that's 0, but this doesn't work with the Pi cam, so I'm going to go to camera 1, which is my USB camera. Okay, so -d, what device are you looking at? You put a space and then /dev/video1. So for me, that's saying that that's going to be my webcam, and then space --list-formats-ext. And so this should show me my webcam. Okay, very good. And do you see all these different sizes that it says I can do? It shows me the sizes, and then it shows me the frame rates that it's capable of. Okay, and then here is a 640 by 360, and you see you've got up here at the top 640 by 480. So I'm going to go ahead and set that to 640 by 480 as the size. But you should be able to use any of those sizes that showed up here under your camera. Now, if you have two webcams, you could also look at /dev/video2. Okay, so you can get all your different sizes there that you can use. Now, the one other thing that I will show you is I don't think that you will get much. For me, the Raspberry Pi camera is video 0, and so this probably won't say very much, yeah. And it just this is all the information that it gives you. But those are the resolutions. So that seems like that would actually work for the Raspberry Pi camera as well, that command. And I do believe that we are ready to jump in and start coding. One of the things that you can just see is that if we are, I'll just make note of this right now because I know where we're going, that if we're going to be using this video one, which is going to be my webcam video capture one, that I can use 640 and 480 as one of the allowed sizes. So that's one of the things that we'll need to know. But let's go ahead and fire up our Visual Studio Code. And you can see that I have created a new folder, which I call NVIDIA. And then inside this NVIDIA folder, I'm going to create a new file. And that new file is going to be called my identify-1.py. You can call yours whatever you want, but that's what I'm going to be calling mine. The good news is I know these fonts are hard to read over here, but I do have a big enough font that you should be able to follow along with me. Now, this is going to be just a few lines of code, but it's going to be a pretty impressive demo. So let's get ready to roll here. So the first thing we're going to do is we spend a lot of time installing these new libraries. We're going to load a couple of them. We are going to import Jetson.Inference. What does Jetson.Inference do? That is the program that is the library that will allow us to look at a frame and find things of interest in the frame, sort of like our face recognition library was in our earlier programs. Then we are going to import some utilities, Jetson.Utils. That library allows us to interact with our display, and it allows us to interact with our camera. Okay, with those things out of the way, we are going to need to do a certain couple of things here. Give me just a second here. I need to get a little bookkeeping done over here. That looks good. Okay, now with those two libraries in, we can go ahead and create our camera. You can remember that when we were doing OpenCV, we did like a video capture type command, cv2.video capture. Well, now we're going to be using the Jetson utilities to control the camera. And so we are going to go ahead and set up the camera as Jetson.Utils, U-T-I-L-S, Jetson.Utils. And then we are going to do GST camera. So you see GST uppercase C for camera. And now we need to give it a width. So we're going to give it 640 for the width and 480 for the height. And then we got to tell it which device. And I'm going to put a dev, a /dev, and then /video1, and that is my web camera. All right, now if you were going to want to just use your Raspberry Pi camera, all you would have to do is right here, you would just tell it that it's camera 0. So you see the Pi cameras are a little bit different beast than the webcams, and you use a kind of like a different way of interacting with them. So if you're going to use your Raspberry Pi camera, you just put a 0 here. I don't have a dual camera. I don't have a dual camera Nano. I'm wondering if you had 2 cameras on your Nano, if the other one would be 1. That would be what I would guess, but I know 0 will work for the one camera setup. So we will go back because I will be using the USB cam on this. So that should set it up. Now we've got to set up a display. So we'll say DISP for display, and that is going to be Jetson.Utils, and then we will make a GL display, just setting up that object. So now I have a cam and I've got a disp. Now I need to tell it a font because I'm going to be interacting with it textual wise, and so I need to say the font is Jetson.Utils.CUDA font. Okay, and there's really not any options that I'm aware of. You just kind of get the font that you get, which is the CUDA font. So now I have a camera set up, I've got my display set up, and I've got my font set up. You can see this is a lot like the kind of mindset that we had in OpenCV. It's just our commands are different. Now this is a little bit different too. Now we're going to go into that go out, grab a frame, do something, show a frame. And before in OpenCV we would just say while true, but here we're going to be a little bit smarter. We're going to say while, okay, display dot is open. Pay attention to the uppercase, lowercase, display all lowercase, dot is with an uppercase I and open with an uppercase O is open. All right. So this just means we're going to fire off a window, and as long as that window is open, the program will run. But when we kill the window, then it will kill the program and exit us out and release the camera and that sort of stuff. So it's kind of like now we're not going to have to do that wait key business. So now we're going to go out and we're going to get a frame, and then we're also going to get returned to us the width of the frame and the height of the frame. And so now it seems like every time we call something or get something returned, we're sending it the width and the height. And when we grab the frame, it gives it back to us. And so this is going to be equal to cam.capture with an uppercase C RGBA. All right, so right off the bat, a couple of other things you notice different than OpenCV. In OpenCV, we were working in the BGR color split space, blue, green, red. Here we are working in the red, green, blue alpha, and that fourth channel is one that's just sort of like opacity and transparency. So if you want to put a box over someone's face that has some degree of opacity, you've got a parameter that you can work with that. So cam is cam.capture RGBA. So now we have a frame. Now we got to figure out what does it see in the frame. So we're going to do that kind of detection step. So what I'm going to say is it's going to tell me the class ID. That means it's going to look, and if it sees a cup, it's going to return to me not the word cup, but a number that would correspond to the word cup. So it would be sort of like you've got a list and it's the position in the list. So class ID, and then also it will tell me how confident it is in its identification. And we do that with simply net.classify. So we're going to net.classify what? Well, we're going to look at the frame, and again we got to tell it the width and the height. Now make sure that you're passing it the width and the height that you got back from the camera, because you set the camera up as 640/480, but what if you messed up and that wasn't one of the allowed ones and therefore it set it to something close nearby? So you want to make sure that you might have asked for this, but you want to make sure that you pass it what it told you it was. So let's say if I said 640/481 I wanted, it might return to me an image that is 640/480. Well, we want to use that width and height here to make sure that things match up. I hope that makes sense. Hope that's not too confusing. So now I have the class ID. So let's say that I could do cup, pen, pencil. Well, it might return the number, the class ID 1, which would be cup, or 2, which would be pen, or 3, which would be pencil. So once we get that class ID, it's a number. Now we got to go look up in a list to see what the word is, what the actual object is that goes with that ID, and we do that rather simply. We can just say the actual item that we found was a net.getClass description. Uppercase G, uppercase C, uppercase D, get class description of what? Well, just the class ID that I just found. All right, so now I should actually know what my item is that I found, and now I want to put that on the frame. So I'm going to do my font, which I've already set up, my font dot what? Overlay text. And so this is going to overlay text, overlay it overlay it on what? Overlay it on my frame that I grabbed. Anytime I use frame, I got to tell it again width, height. Okay, and now what do I want to overlay? I want to overlay a word. Well, what word do I want to overlay? Item. whatever that item was that I found. So I'm going to be labeling that frame with the word item, which might be cup or pencil or pen or whatever. And now I don't want it up in the very top corner, so I'm going to come down about 5 and scoot over about 5. So I'm going to kind of give it a X and a Y offset of about 5 pixels, so I'm not jammed all the way in the corner. Now, what color do I want the font? Well, I'm going to say I want it font dot magenta, so the text is going to be magenta. And then what do I want the background? The background of the letters, I'll make it font dot blue, and the obvious colors it will know, like this. Okay, now I've got the image, I know what is in the image, and I have overlaid the frame with the word, what it is. Now I just got to show. So remember, I do an IM show in CV2. Well, instead of IM show, I will do a, and this was disp, my display object up here. It will be disp dot render once, and then what am I going to render? I'm going to render the frame, and remember that frame has the text on it, and again, you always tell it width and height. Okay, so that's a pretty simple little program. And even though all these commands are new, I think you should kind of recognize what we're doing here. So let's go ahead and let's run this thing and see all of our problems. Now, ooh, invalid syntax, Jetson utils. What did I do wrong there? That looks so right. Oh, impart. I'm not going to impart, I'm going to import. All right, now I'm going to warn you, the first time you run this, it's going to take 5 minutes to run, because the tensor and all those types of things are going to go in and optimize, and it's going to teach itself how to learn fast. I mean, it's going to teach itself how to recognize fast. So the first time you run it, it's going to sit and optimize itself for about 5 minutes. But you're going to see a lot of stuff happening. It's not going to hang, but it's going to take you a lot longer than me because I've already run this on this machine. So let's go ahead and say run Python file in terminal. Ooh, it still doesn't like it. What does it not like? Failed to create device. We will come up here, and I have 640 by 480, and I've got /dev/video1, and that is line 4. Utils, GST camera. Can you guys see what I did wrong there? 640 by 480. I forgot the /dev. Okay, let me show you. You've got to go back to root /dev/video1. Right, you've got to go all the way back to the root. You got to have that leading slash, and this time I think it should run. It's looking good, looking good. What did it not like that time? Line 8. Display. I didn't call it display, I called it disp, right? So when I name my object up here, I called it disp, so I got to call it disp there. Run Python file in terminal. Okay, it did not like that. Net is not defined. Oh, I didn't set up my net. That was not good. Okay, so what object detection network are we going to use? I've got to set that up. Net is going to be equal to jetson.inference.imageNet. So I got to tell it what training set, what network, what model I'm going to use to recognize images. And remember, we downloaded like a dozen of them. Well, the one we are going to use is Google Net. Now you can go in and use the other ones and to kind of play around with the other ones, but they need to be the ImageNet models, not the DetectNet models. This program will work with the different ImageNet models. So you can try the different ones, and you can go back and look and see the ones that we have. Okay, so I am going to come in now, and I am going to run this thing. And this is where it's going to take you 5 minutes, right? It's going to take 5 minutes for you to optimize, but I've run this before, so it'll just take maybe 30 seconds. But this TRT is going to take a while for you to optimize. Okay, well, look at that right off the bat. Boom! Look at that. This is my green screen back behind me, but what does it think? It thinks the green screen is a shower curtain. Well, I would say that's a pretty darn good guess. And now let's just see if I put this up here. Look at that. A pill bottle. Got it right off the bat. Giddy up. That was pretty impressive, wasn't it? What if I put this? It's going to recognize that as it says a goblet. I guess that would be a goblet. That is a coffee cup. You might ask me, why is my coffee cup so dirty? Well, it's because I like to season my coffee cups, and so I do not wash them. It actually enhances the flavor in my mind. Okay, let's see what we can do here. Drumstick, paintbrush. Okay, ballpoint pen. There, it got it. Ballpoint pen. That is pretty darn good. Let's see what other things I've got here. I've got a camera. Let me turn the camera on. Okay, and then if I come here, let's see if it can recognize it as a camera. It had it there for a second. I think this will work better if I point down and give it a better view. Okay, so let's give it a reflex camera. There, it got it pretty good, just needed the right view. I come over here, mouse, computer mouse. I come over here and I've got a, it looks at it as a whole notebook, but it's got the computer keyboard. That is pretty good. Look at that. It actually recognizes the space bar. Keyboard. Okay, that's pretty good. Computer keyboard. Look up here. It sees it as a monitor. Wow, this is pretty impressive. And let's see if I can, you see it sees my lighting system as an umbrella. Over here, it sees that I've got a desk. Over here, oh, look at that. It saw the soap dispenser on the wall, and then it thinks of it as a rocking chair. Let me see if I can give it a little better. I'm not sure why it sees that as a rocking chair or a rocker. That certainly doesn't look like a rocking chair, but let's see if I can give it a little different view there. Okay, now folding chair is a little bit better of a guess. And so this thing, you can see just looking around the room, it's able to recognize quite a bit of different stuff. Desktop computer, again, desk. Let's just see if I just point it out there. It sees a lot of desks out there. That's pretty good. Now it sees a bunch of books over there on the thing, and so it was kind of guessing library. Can't quite see my airplane all the way back in the back. So anyway, you can see that this thing is finding a lot of different stuff. And we're going to spend some time. You're really going to learn a lot about what is going on with this software, but I mean with this library. But I just think it's pretty neat that in just a few minutes we were able to write our first image recognition program. And so this is kind of what we're going to be doing moving forward in the future, is learning more and more about how to identify objects. And so that was just sort of a quick demo, and we will be going into this type of thing in more detail in future lessons. Okay, this was pretty much fun. I enjoyed getting the program written. It was really a lot of work on the installations, and I felt like we should at least have a little bit of fun at the end of the lesson. So next week we'll come back and we'll really start developing this a lot more with this library. Plus, I promise you next week I'll have a better way for you to see which libraries are at your disposal. Okay, guys, if you like this video, give me a thumbs up. Remember to subscribe to the channel. When you subscribe, make sure you ring that bell so you'll get notifications when my future lessons come out. And I will talk to you guys later.